Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, the Science and Technology channel. Got an interesting one this morning.
Yeah, we're talking about a science. This is definitely a science topic and kind of weird, but and I think Steve's going to get into this a little bit more. It kind of ties into what we talked about almost 2 years ago, August.
Yeah.
Regarding a big dip or pit in the ocean. But anyway, Steve will get into that. But yeah, this is cool. It involves satellite imaging and measuring waves. So
yeah, it could be great if we could get it working. I mean, around the globe. A powerful tsunami seen from space is overturning what scientists thought they knew about how these waves travel. A satellite designed to measure ocean surface height delivered a remarkable result when a powerful earthquake near Russia's Kamchatka Peninsula unleashed a tsunami that spread across the Pacific in late July. Would you like to know more?
Scientists report in the seismic record published on November 26th of last year that the surface water ocean topography, or SWOT, SWOT, a satellite recorded the first high-resolution space-based track of a major tsunami generated by a subduction zone earthquake. The new view revealed a far more complicated wave pattern than expected, with energy spreading and scattering across the ocean. The findings could help researchers better understand how tsunamis move and how they may impact coastlines.
Now, something that I kind of don't understand is, so you got a satellite up here. Is it using a laser to ping off from the ocean to get the elevation of the ocean? Because you're going to have to measure it as measured around it, right? Well, are they triangulating? And then that brings us back to that story in August of 2024, Scott, that we reported on an Indian Ocean geode low. If you recall, it was a gravity hole east of the Horn of Africa and just south of Sri Lanka that on average is 348 feet below mean sea level, 1.2 million square miles.
It's a huge
cliff. It's huge.
It's a huge area. Yeah. Not only a huge dip, but it's a huge area.
That was an interesting segment. What did we say, August 8th, Scott?
Yeah, around the beginning of the first week of August in 2024, we did that.
And then the next day we talked about protoplanet Theia slamming into Earth and wondered if there could be something there. You know, maybe all the metals in that proto-Earth are at that location that's causing the dip. I don't know.
Yeah,
but it's really fascinating.
Yeah. So when you're talking about this map or the satellite vision, so when you do. When you go on Google Maps or Maps on your phone or your device, and you're seeing an overhead of your area or your property or whatever you're looking at, and then you can go over to like a 3D or 2D reading, and that will bring you into ground level. You can adjust that to where you can bring it in like worm or ground level and see across. I don't know how they do that.
It's because they're so you got the satellite that's going down and looking, but then when you go less than 100 feet or 200 feet, whatever,
right? Now
it's these cars that are driving around with the cameras,
right,
that are capturing everything. That it transitions to that, so you can see, you can panoramic right, panoramic left, at ground level.
Yeah, and of course it's not live imaging like you
right,
like
it's
you
recorded.
You see on movies or
Could be
TV
months old.
Yeah.
Or years.
So, I mean, I don't know how they would do that with a wave that's moving. Yeah. Current time with a wave. That would be.
And you mentioned earlier before the segment, how do you mark that? It should be marked. And I'm like, Scott, 1.2 million square miles. Not like anybody can put buoys out there. And the buoys would just float off, with the current or with other seismic waves, rogue waves or whatever.
Right.
So, because, Scott, you were concerned, why would ships want to travel into that? Well, maybe they've got it on their satellite imagery. They all have technological ships, it's not like a sailing ship.
Yeah.
Where they'd see that on the screen, and just
what do they call that? A sextant? Is that what that device is called when they measured the
Yeah, well, that
distance.
puts your location. That puts your location based on the stars,
Right.
but it doesn't show elevation.
Yeah, we've come a little ways past that. So,
Yeah.
but,
Okay, continue our story. Angel Rees Angulo of the University of Iceland and his team combined the satellite observations with readings from DART, Deep Ocean Assessment and Reporting of Tsunamis, buoys positioned along the tsunami's path. Together, the data provided new insight into the magnitude 8.8 earthquake that struck on July 29th in the Kamchatka subduction zone. It ranks as the sixth largest earthquake recorded worldwide since 1900.
okay, here's a quote. I think of SWAT data as a new pair of glasses, says Ruiz Angulo. Going on with the quote, before, with darts, we could only see the tsunami at specific points in the vastness of the ocean. There have been other satellites before, but they only see a thin line across the tsunami in the best case scenario. Now, with the SWAT, we can capture a swath up to about 120 kilometers wide. That's pretty wide, with unprecedented high-resolution data of the sea surface, unquote.
SWAT launched in December 2022 through a partnership between NASA and the French space agency Centre National d'Études Spatiales. Well, I butchered that French. Pardon my French. Was built to map Earth's surface water on a global scale.
Ruiz Angulo noted that he and co-author Charlie de Marez had spent more than 2 years studying the SWAT data to analyze ocean features such as small eddies. Quote, we had been analyzing SWAT data for over 2 years, understanding different processes in the ocean like small eddies, never imagining that we would be fortunate enough to capture a tsunami.
Scientists have long assumed that very large tsunamis behave as non-dispersive waves. Because that was in quotes here, because their wavelengths are longer than the depth of the ocean, they are expected to travel largely intact as a single wave rather than breaking apart into multiple waves. Yeah, okay.
Another quote here. The SWAT data from this event has challenged the idea of big tsunamis being non-dispersive, and that's according to Ruiz Angulo. Instead, the satellite observation showed evidence of dispersion where the wave energy spreads into multiple components. Computer simulations that included this type of behavior matched the real world data more closely than traditional models.
Continuing a quote here, or starting a quote, the main impact that this observation has for tsunami modelers is that we're missing something in the models we used to run, Luis Angel added. This extra variability could represent that the main wave could be modulated by the trailing waves as it approaches some coast. We would need to quantify the excess of dispersive energy and evaluate if it has an impact that was not considered before.
The team also compared their findings with earlier tsunami forecasts that were based on seismic and land deformation measurements. Those earlier predictions did not fully align with what DART instruments actually recorded. In particular, the modeled arrival date times at 2 monitoring sites were off, arriving earlier at one and later at the other than observed.
This is what I don't like about modeling predictions, because 1 or 2 variables that you don't account for, it blows the whole thing, or you have significant variances. And these astrophysicists, when they talk about planets millions of light years away or hundreds of light years away, they're making these inferences based on modeling. And if they get one variable wrong, then their idea is just an idea, you know?
Yeah.
So to resolve this mismatch, the researchers used the buoy data in an approach known as inversion to refine their understanding of the earthquake's source. Their updated analysis indicates the rupture extended farther south than previously believed and stretched about 400 kilometers. That is significantly longer than the 300 kilometers estimated by earlier models.
Quote again, ever since the 2011 magnitude 9.0 Tohoku Oki earthquake in Japan, and that, I'm trying to think back, is that the one that really messed up with the nuclear power plants and stuff?
Yeah.
We realized that tsunami data had really valuable information for constraining shallow slip, and that's according to the study by co-author Diego Melgar.
Melgar explained that researchers have been working on to better integrate DART data into these analyses. Quote, but still not always done because the hydrodynamic models needed to model darts are very different than the seismic wave propagation ones for the modeling the solid earth data. But as shown here, it is really important we mix as many types of data as possible, Melgar said.
The Kamchatka region has produced some of the largest tsunamis on record. A magnitude 9.0 earthquake in 1952 triggered a massive Pacific-wide event that ultimately led to the creation of an international warning system. That system played a role in issuing alerts during the 2025 tsunami.
Researchers say the new satellite-based observations could eventually improve real-time forecasting. Quote, with some luck, maybe one day results like ours can be used to justify why these satellite observations are needed for real or near real-time forecasting, Reese Angelos said.
Yeah, so, I mean, again, I'm a simple guy here, but I'm thinking if they could track these tsunamis, they could be able to warn if they think that because of the size of it, it's going to get to land, right?
Yeah.
And that way, not everybody across the Pacific Rim or wherever, which is a big area, is panicking because of these tsunamis. So, yeah, I could see where this would be very, very valuable. So.
Okay, folks, thanks for joining us. If you want to go back to that episode, August 8th, 2024, about the Indian Ocean geoid low, really fascinating.
Yeah, that should still be on YouTube, right?
Yeah.
So, okay. Yeah, and let us know if you want us to revisit that. So see if there's any updates on that.
We appreciate it.
Take care, everyone. Thanks.